Here I am playing a recording made on 2 meters. The recording is 6 seconds long only, and it's repeating over and over again. There is interference here. The recording is made with a soft rock. You can see the characteristic notch at the center here. And I'm listening to a very weak signal that we can see here in the waterfall. In the baseband waterfall we can see it. It looks like there are 2 signals. I have enabled the second FFT, and I click down here to enable the oscilloscope for the second time function. And here you can see there are interference pulses. I can click on the smart blanker because the system is calibrated, and calibration comes with the recorded files when recording in the Linrad.raw format. So I click here for the smart blanker, and we can see pulses have essentially disappeared. The noise floor is much lower. It goes from green to dark blue. On the S-meter graph we can see that the improvement is about 5 dB. And on the RMS noise, the peak noise is different. Some noise peaks are not changed at all. They are at the same level as before. Looks like they are even bigger, but that seems to be an artifact. And you can see from here to here is the 6 seconds of the recording, because it's repeating over and over again. We can now clearly see there are 2 signals here. This is the smart blanker only, and I can put it to manual by clicking here once again and try what happens when I move the blanker threshold. So I go upwards a little bit. And it doesn't matter until here. So I go back again. It's at this point. From here to here is 20 decibels. So from the noise floor to the threshold there is something like 13 dB or so. I can also move it very close, and you can see it doesn't make any difference. The smart blanker is fairly smart. So I put the smart blanker threshold a little bit above the noise floor, like this. And to know what goes on now, I can increase the gain of the oscilloscope. It's down here. I click on the plus. And you see there are occasional pulses coming up where the blanker fails. And those are responsible for the big excursions on the white track, the peak power. I can now enable also the dumb blanker here, and I put it manual, and now you can see there are no more any pulses. And you can see in the waterfall the noise floor is more dark blue, and you can see the RMS noise dropped by maybe 1.5 dB, but the peak noise dropped significantly, the white track here. And it seems I was clicking on the frequency. I have to go back to the signal here. So we can see now much better. There are many spurs Some of them are red, means they are considered strong signals, although they are not very strong. I can click here. That is the automatic spur removal. It now removes 25 or something spurs, and you can see many of the lines in the waterfall have disappeared. It doesn't work particularly well because 6 seconds is a very short time for this. Every time the recording restarts, there is a phase discontinuity and the notches for the spur removal are disturbed. This spur removal has a bandwidth of a fraction of a hertz, or maybe it was, no, a fraction of a hertz, I think. I will see later. So it doesn't interfere at all with any signals that could be of interest. I will demonstrate the parameters used here, pressing X and parameters. And then enter, and enter, and enter. Spur time constant is 0.4 seconds, so it is bandwidth of 2.5 hertz, so it was not quite correct what I said before. And here we are. So this is a little bit how to use Linrad in a non-rural environment.